Welcome to the HydroStor Stormwater Chamber installation video. HydroStor chamber systems are a highly effective way to maximize commercial land usage by providing underground stormwater storage and recharge. Let's get started. Upon delivery to the project site, visually inspect the chambers and end caps for damage and to ensure accurate quantities. After inspection, unload the pallets with a forklift with a minimum of 72-inch forks. Place pallets in an area that is flat, free of debris, and away from construction traffic to avoid potential damage. Chambers and end caps may remain on the pallets until they're ready to be installed. HydroStor chambers feature integrated handles to allow them to easily be moved and set in place. To remove the chambers from the pallets, carefully cut and remove the banding from around the chambers. With two people, use the handles to lift the chambers off the pallet and carry them into place. Warning: the chambers must not be removed from the stack by pushing them off from one side. Removing the chambers in this manner may result in chamber damage, injuries, or even death. Due to the inherent hazards associated with excavation, special precautions should be taken. Obey all federal, state, and local guidelines for excavation safety. Using the project plans, excavate the chamber system bed, making sure to allow enough space for the entire system, including the chambers and manifolds. Ensure you have a minimum of 12 inches of excavation between the side walls and the chamber system, a minimum of 6 inches for HS-180 and 12 inches for the HS-31, HS-75, and HS-290 between the sidewall and the end caps. A stable foundation is required for installation. If water or unstable soils are present, take appropriate measures to ensure you have a stable foundation. The method used to remedy the issue will depend on your specific circumstance. The design engineer should be consulted to determine the appropriate method based on the site conditions. Once your excavation is deemed stable, place a 4 to 6 ounce ASHTO M288 Class 2 or 3 nonwoven filter fabric on the bed bottom as a separation layer. When placing the fabric, be sure to maintain a 24-inch overlap at all seams. After the fabric has been laid out, place a level base of 3/4 of an inch to 2-inch clean, crushed, angular stone over the entire excavated bottom. The bedding should be a minimum of 9 inches for the HS-180 and HS-290 chambers and a minimum of 6 inches for the HS-75 and HS-31 chambers. Additional bedding stone may be necessary based on the native soil conditions and the burial depth of the chambers. Consult the Prinsco representative for minimum recommendations. Using a vibratory compactor, compact the stone base to achieve a flat, level surface. If specified in the project plans, a perimeter underdrain may be laid in the stone bedding. Be sure it's not installed under a chamber footing. A manifold is used to distribute the stormwater to the chamber rows. A manifold system will typically consist of Prinsco gold flow dual-wall pipe fittings and split-band couplers. Using project plans, lay out the manifold system at this time. To alleviate the potential for scour at the inlet locations, lay a 12.5-foot wide strip of an ASHTO M288 Class 1 woven stabilization geotextile along the entire length of the manifold mainline, adequately covering the bedding beneath the inlet locations. The fabric should extend a minimum of 12 inches in front of the end caps. Position the end caps of each row with the inlet pipes. At the required locations and elevations, core an opening in the end cap the approximate outside diameter of the pipe and insert the inlet pipe. The inlet pipe should penetrate 12 inches into the end cap. Repeat this process for each row. Cover any voids on the end caps greater than 3/4 of an inch with a non-woven geotextile to prevent infiltration of the backfill material. Position the chambers in line with the end caps, noting their orientation. The chambers are stamped with arrows showing the direction for installation. The end caps will fit over the first rib of the chambers. The assembly of each row is achieved by overtopping the last rib of the initial chamber with the first rib of the succeeding chamber. End caps should be used to terminate each row of chambers. During the assembly process, do not extend the chamber rows beyond the reach of the backfill placement equipment. Maintaining a minimum clear space between each row is required for adequate structural support. Clear space should be a minimum of 8.5 inches for the HS-290, 5 inches for the HS-180, 6 inches for the HS-75, and 3 inches for the HS-31. A spacer is recommended to maintain the required spacing. Considering chambers have open bottoms, it is essential to utilize a pre-treatment system to remove sediment and debris before the influent enters the chamber system. Prinsco recommends pre-treatment by using either a Prinsco Stormwater Quality Unit and/or a chamber sediment row. It is important to consider the local water quality regulatory requirements and the expected influent contamination. Inspection ports are not required. However, they may be installed to monitor the sediment and debris level within the system. Using the project plans, identify which chambers should be fitted with inspection ports. Using a hole saw, cut out the opening at the appropriate location. A rubber gasket connection can be used to connect Schedule 40 or SR35 PVC pipe and fittings to build the inspection port. For the HS-180 and HS-290 chambers, a 4-inch vent or inspection port may be drilled in the valley between the corrugations. The HS-31 and HS-75 chambers are equipped with one circular cutout point to accommodate a 4-inch diameter inspection port. The backfill and chambers function together as a structural system to support the soil overburden and vehicular live loads. Therefore, proper backfill material selection and placement is critical. Backfill material used for embedment, anchoring, and surrounding areas should comprise of a 3/4 to 2-inch clean, crushed, angular stone. Placement of backfill material is best accomplished by using the long reach of an excavator or stone shooter conveyor system. No construction equipment shall be situated on top of the chamber system without the minimum cover specified. Compaction of the crushed stone around the chambers is not required. However, it is critical to ensure that the backfill is adequately knifed in around the manifolds and between the chamber corrugations. In order to prevent chamber shifting and to maintain the appropriate row spacing, carefully deposit the stone evenly along the center line of the chamber, allowing the stone depth between the rows to rise equally. During this phase, stone height between rows should not differ by more than 12 inches. After the anchoring is complete, stone placement may continue to surround the chambers and around the perimeter. The embedded backfill stone should fully encompass the chambers and extend evenly from the chambers to the sidewalls of the excavation. After the required embedment backfill has been placed, 12 inches for the HS-180 and HS-290 and 6 inches for the HS-75 and HS-31, a small, lightweight tracked dozer may be used to finalize the grading of cover stone. Equipment should run parallel to the chamber rows at all times. Wheel and roller loads are not allowed at this time. After the embedment backfill has been evenly spread, the entire top of the stone bed should be covered with a layer of ASHTO M288 Class 2 or 3 nonwoven separation and filtration geotextile, overlapping seams a minimum of 24 inches. Utilizing an excavator positioned next to the chamber rows, the initial backfill can now be placed over the top of the fabric. The initial backfill should be a well-graded granular material. After a minimum of 24 inches for the HS-290, 18 inches for the HS-180 and HS-75, and 16 inches for the HS-31 has been placed, compaction of the backfill may begin. It is recommended that the compaction equipment travels parallel with rows. After the initial backfill has been placed and compacted, the final backfill may be placed to reach the required ground elevation. Measured from the top of the chambers to the bottom of pavement, chambers should have a minimum cover of 24 inches for the HS-290, 18 inches for the HS-180 and HS-75, and 16 inches for the HS-31 for H20 vehicle loading. If pavement is not to be used, the cover should be increased to a minimum of 30 inches of cover for the HS-290, 24 inches of cover for the HS-180 and HS-75, and 22 inches for the HS-31 for vehicular loading. If the chambers will experience loading from construction equipment while the project is still being constructed, temporary fill may be placed over the system during construction and removed after the heavy equipment traffic is rerouted. The maximum burial depth for the HS-290 is 7 feet and 8 feet for HS-180 HS75 and HS31 chambers. Proper installation of your chamber system is critical to ensure structural integrity and maximum service life. This can be achieved by following the steps laid out in this installation guide. They were: easy handling with 2 people. Make sure to excavate adequate room for the system and ensure you have a stable foundation. Assemble chambers in the proper direction as indicated by the arrows on the chamber. Install pretreatment structure and/or sediment row. Backfill evenly to prevent chamber shifting. Be sure to check the minimum and maximum cover heights. For more information on the HydroStor chamber, visit prinsco.com/HydroStor.